So as you can see, when we started working backwards, right? When coming down this way, we were multiplying by 0.33, right? As we're going backwards, then we're dividing by 0.33. If you take 0.11 and you divide that by 0.33, the number actually grows. Divide by 0.33, the number grows. Divide by 0.33, that's what we're doing all the way up here. Well, you can see that this exponential growth, here's -3, it's up here at 81, then 27, pretty steep, huh? 27's right about there. -19, right about there. 0.3 here. Okay, that's our y-intercept, makes sense. 0.3, just a little bit below 5 there. 1.1, and then it barely gets steep, huh? So it comes down, flattens out. And guess what? It's never going to cross 0. It's going to get infinitely close, but it never actually crosses 0. It gets closer, 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 closer down there, but never crosses. Okay, we'll stop the video there. I will make that line more solid, but I don't want to take the video. So as you can see, I made my line more solid, made it a little bit better, all right? And because it's not a dotted line, I was just making the dotted line so that I could help trace it out a little bit better. There you go, exponential decay. Steep drop down, flattens out. Okay, we'll do another one. Okay, so what I've done here is I've decided to use a decimal that there's no way I could do the numbers in my head. All right, when I multiply by 0.15, I mean, I'd probably grab a calculator and do that. And the reason why I'm doing that is because I want to show you exactly how you can work the system and you know, not really, you're going to use a calculator. You don't have to necessarily be able to do this in your head. Okay, so the one place that we're always going to start is where? So what is our y-intercept? Tony, what's that going to be?
8.
Okay, that's our beginning value right there, 8. Okay, now Tawny and I, while I was doing some erasing and stuff, she's like, well, I don't get why that is always 8. And like I said, she hasn't seen all my other videos and stuff like that. So I think that that's a good, important thing to look at. Why is that 8? So if I plug 0 in for x right here, right? Remember, that's what I'm always doing here. And that's what I'm going to do in example number 4. But if I plug 0 in for x, okay, well, what is 0.15 times 0? Well, anything raised to the 0 power is 1. Okay, 1 times 8, 8. Okay, so that's why that's going to work every time. Whenever you plug 0 in, that's going to make this whole thing 1. 1 times whatever's there. There you go. Okay, now one of the big things I'm trying to do is show you that exponential is a multiply pattern. All right, and I'm also trying to show you how each one of these parts of this equation work. So so now if I take 8 and I multiply that by 0.15, what's that going to give me?
1.2.
So this is going to fall really fast. 1.2. 1.2. Okay, multiply that by 1.5.
0.18.
Okay. 0.18. Multiply that by 0.15.
0.02. Do you want 225?
No, that works. 0.02 works. Okay. So now, instead of so in this case we were multiplying by 0.15, right? Multiply by 0.15. Okay, when we're going backwards, what do we need to be doing?
Divided by.
Okay, so we're dividing by 0.15. This number's probably going to grow too fast, but I mean, not necessarily too fast, but it's just going to be really steep.
53.3.
Yeah, again, 53.3, okay. We'll divide that by 0.15.
355.5.
Yeah. I hate this example. 355 point what?
55.
Okay, and then finally?
2,370.37.
2,370.37. Okay. Yikes. But anyway, that's okay. That'll give us a little bit of a graphing challenge, but not a big deal. That we need to see one of those anyway. Okay, so as you can see here, I had to. This isn't the greatest because that chart's pretty steep. Okay, 2,370. Well, here's 2,500, so 2,370 is going to be right about there. -3. Okay, something like that. It doesn't have to be perfect. If I see your numbers here, that's going to be fine. Then guess what? It drops all the way down to 355. Well, here's 100, 200, 355 is going to be right about there. Okay, in your assignment, I'm going to try to avoid some stuff like this. -153. Well, it's just right there between 100, and then it just really starts dropping 8. I mean, man, that's there, there, there. So it's kind of crazy how this one looks. Super steep, and then flattens out. All right, I'm gonna take a minute to sketch this in. So there it is sketched, right? You get the idea, I hope, and then I'm gonna show you one more thing that I can do with example number 4, and then I'll give you a few problems to do on your own. Okay. So one of the things that Tani kind of mentioned was that I was using patterns, you know, the pattern of, hey, I know that 3's there, then I'm multiplying by 0.6 as we go down and dividing by 0.6 as we come backwards. And if you want to keep doing that, that's fine. I'm perfectly happy with that. I like the idea of knowing the pattern, but I also want you to see this. In reality, all we're really doing is putting -3 right in there, just like that. Okay, then that's really what I'm doing for every number, right? When I plug a 0 in here, 0.6 times 0 is 1. 1 times 3 is 3. So we know that that value right there is 3, right? And that's, so I'm going to do this real quick with Tani. Okay, so Tani, put in 0.6.
Okay.
Then raise it to the -3rd power.
Okay.
And then multiply that by 3 times 3.
Multiply all of that by 3?
Just put times 3.
Okay.
What'd you get?
13.88.
Okay. 13.89.
9.
Okay, so now if I do the next one, I'm going to go y equals 3 times 0.6 raised to the -2. All right, so start here, Tani, 0.6.
Mm-hmm.
Raise it to the -2.
Okay.
And then
Times by 3.
Then multiply by 3.
8.34. Oh, sorry. No, 8.33.
0.33. Okay, so also the other thing you'll realize is if she multiplied 13.89 times 0.6, she's going to get that value right there. All right, let's just do this one more time so that we can see a pattern. So we have y equals 3 times 0.6 raised to the -1. So go 0.6 raised to the -1.
1.6.
And then multiply that by 3.
And then times 3. 5.
Exactly 5?
Mm-hmm.
Okay, well that makes sense. Okay, so you take that, multiply it by 0.6, and you're going to get 5. Multiply that by 0.6, you're going to get 3. And you could do that pattern all the way down as well. All right, so let's just finish, instead of plugging it in every time, let's just use our pattern. So if we go 3 times 0.6.
1.8.
1.8. See how most of the time I fall back into just doing the pattern because I think it's so much easier if you just use the pattern. But hey, we know we're multiplying by 0.6. Okay, keep going. 1.8 times 0.6.
1.08.
1.08. And then times that by 0.6.
0.65.
0.65. Okay, now we'll graph it. Okay, so I didn't want to burn up all of our video time just by me graphing. So there you see I've graphed it. Again, you see the steep decline and then the tail, okay? And tomorrow, we're going to talk about how this shape of this curve actually teaches you how you should consider buying cars, okay? Especially if you're middle to lower class like me, then you can't afford real expensive cars. But anyway, we'll talk about that more tomorrow. Okay, so this is exponential decay. In these 4 examples, I don't know if I've done a great job of teaching you exactly what to do, but as you can see, I want the table, I want the graph, and every graph should have this steep decline with an asymptote at the end, right? And so if you're having any questions on that, please feel free to call me, and we'll go over it. But I'm going to show you the 5 problems that we're going to do, and then that's going to be it for the day. All right, I only did 4 problems because guess what? If you know these 4 problems, the 5th one isn't going to prove anymore. Okay? If you don't know how to do this, folks, give me a call. All right? There's my phone number at the bottom. 406-651-9072. Second to last assignment, peeps. Tomorrow, I'm going to give an assignment based on us going out and buying a car and trying to make some good decisions on what kind of car we should get. All right? Have a good day.